In today's lesson, you're going to use the data that you collected for the control chart project. And if you remember, when we did that project, there was one column in our table that was labeled bin, and we're going to go back and fill that in today. We're also going to take that data and we're going to find the mean, the median, and the mode, which you probably have heard of. You probably know these things. We're going to do that for a smaller population of data. And then you're going to create a histogram. Some of you did. Jack already did one, but he did it on the computer. I'm going to have you do a histogram by hand, and we're going to discuss that a little bit in more detail. But that's it. This is a fairly easy project. We're finishing data and probability with this, or maybe a quiz. But then we're going to start with hydraulics after Easter break. So let's say I asked all 14 of you, how many of you have been to Cape Cod? And I'm just going to record the responses. So maybe Omar says, well, I've never been there. That's a 0. And then Ellender's like, well, I went there once when I was a kid. Then maybe the two Jacks, Rumble and Foster, have each been there twice. Maybe the one and the only Zach Lutzky's actually been there 5 times. But then Caleb hasn't been there at all. I'm not going to name every kid, but let's just say we keep going down the list. And finally we get to, who haven't we mentioned? Somebody like RJ. And RJ says, well, my grandmother lives there. I've actually been there 16 times. Okay, so we're actually going to have to go back and put some commas in here because that's the only double-digit response we got. And then the last few kids, we get some 1s and another 0. Okay, so that's the total population of data that we have. So to get the mean is just the average of the data points. So that's pretty easy. We add them all up and we get a total of 33, and we divide that by 14, and that gives us an average. And we were using X bar for average, so we'll use X bar. So it gives us an average of 2.4 visits to Cape Cod. So how is that different than the median? So the median is the point that's in the middle of the data. Well, it may be useful to rewrite the data. So we have 4 zeros. We have 5 1s. 1, 2, 3, 4, 5. How many 2s? We have 2. We have a couple of 2s. Then we have a 3, a 5, and a 16. When we write them out like this, this also helps in finding the mode. Just looking back, the mode is the point that occurs most often. So it's pretty clear that since we have 5 1s, that 1 in this case is the mode. But to get the median, we just want to find the point in the middle, so we just start crossing off 1 from either side. And pretty soon it's going to be obvious that the mode, or the median, is going to be, it's actually between 2 1s, so the median is going to be 1. So median is 1 also. And I did it this way for a reason, because really RJ's data point was somewhat of an outlier here, and it skewed the average upward. This happens a lot, which is why median is sometimes a better way of looking at data, which is to say that half the values are above, half the values are below. Now, what if we got down to those last 2 points, which I think were these 2 points? Say we were in between a 2 and a 3, then the median would be 2.5. You would just divide the difference between the two. So you're going to be telling me on your set of data the mean, median, and mode. And then you're going to make a histogram, and let's talk a little bit more about histograms. So this is a histogram, and you're going to be using your data, whether you were measuring peanuts or glass beads or almonds or raisins, whatever you measured, you're going to take that data and put it into a frequency histogram. So it's similar to what we did with the control chart, but it has more of a vertical feel, and this is a much more common way in a meeting. It's a quick way of looking at a distribution of data. And if it's a normal distribution, it will almost always look like this one looks like a bell, which is why it's often called like a bell-shaped curve. And the bell is usually centered around the median. If you have a skewed or a non-normal distribution, then you might have something that looks more like, this. And that would be an indicator that it's a non-normal distribution. Okay, the one that they're showing here is pretty normal. Like it looks like if there was another small bin here of older people, then it would be almost perfectly normal. But it's still a pretty normal distribution. And it doesn't really say what this is. It's showing, it's properly labeled with, the number of people on the y-axis, which is always going to be the number of things, and then it's showing age group in years on the x-axis. So the first thing you need to do to make one is determine the total range of data, which you should already have. You should already have that range of data, which in your case was usually like the length of, like, say, an almond or a peanut or something like that. So you should have the total range of data already. And the range of data is sampled into bins, which represent all samples that fall into the equal portions of the range. In the example above, the range of 30 years was broken into 6 bins of 5 years each. Okay, so for example, this was probably something like this. This could be like the frequency histogram of people, the ages of people that maybe attended like a robotics competition or something. So if you look at this bin here, that's 0 to 5-year-olds. So not too many little kids are going to get dragged to an event like that, but maybe some parents do bring some. So maybe there's like 2 or 3 based on that. And you can see the biggest number are the 16 to 20-year-olds, the teenagers that are in the competition, and there's slightly over 50 of them. So there's something called the Rice rule that you're going to need to use to determine the number of bins. So the number of bins is 2 times n to the 1/3, where n is the number of samples. Now in your case it was 30 samples. And if you lost that data or you wanted to do it again, or if I wrote a comment on yours that your data was wrong, you may want to just do something else. To take 30 other readings. So you're going to take n to the 1/3, just so you know, on most calculators, if you're doing something like, say you wanted, 2 would be a bad number, but say you wanted to do 12 to the 1/3 power. On your calculator, you would say 12, and then you would look for this button, which will raise it to any power. So 12, and then you're going to raise it into, and then you probably want to do parentheses to the 1/3 power. Of course, I haven't even done that, but I'll do that just to make sure that works. I'm doing it on my calculator, and yeah, that comes out to be 2.28. Okay, so you're going to do that, and in this case, they came out with 5.54, so you can't have that number of bins, so you have to round it either up or down. So that one's rounded up to 6 bins, which is why they have 6 different blocks on the diagram. These being the blocks here, so they have 6 different blocks. So that's pretty much the rest of the project. You're going to create a frequency histogram for your data. So you're going to go back to the original table, and you had, that columns that said bins. So you're going to do the Rice rule, figure out how many bins you have, label them. I would just label them going across like 1, 2, 3, 4, 5. You might have 7 or 8 of them. And then you're going to, for each data point, just assign it to a bin. Then you're going to count up the bins, and you're going to create your histogram. The one other thing I would like you to do is then you're going to comment on your histogram. Is it a normal histogram? Is it a skewed or abnormal histogram? And that's it. That's the project. So turn that in on Schoology. Have a good April break. We'll see you after the break for hydraulics.